Today's lesson is on vertex form of quadratics. So, you don't have to write this part down, but it's just kind of a reminder. Linear function, there's all these different forms. Y equals mx plus b, ax plus by equals c. So we have these different forms, and these different forms give us different information. So same idea with quadratics. We have been working with standard form, which is the ax squared plus bx plus c. And now we're going to look at vertex form, which is a, and then in parentheses, x minus h squared plus k. And this might look confusing, but we will have numbers in for the a, the h, and the k. So here's two examples. You could have y equals 2, and then x minus 3 squared plus 4. Now, it's in vertex form because the vertex you can get by just looking at the function. It's h and it's k. So in this case, the h is 3, a positive 3, and then the k is positive 4. So the vertex of your parabola would be 3, 4. And then another example, y equals x plus 5 squared minus 7. We don't always have that leading coefficient. In this case, what it means is it's just 1. And then notice how when we had minus 3, our formula is supposed to be minus. So when we have minus 3, it actually is a positive 3. So when we change the formula to plus 5, what that means is actually the vertex is at negative 5, negative 7. So first we'll do one example where we start in vertex form and we will convert to standard form. But really the point of this lesson is to start in standard form and convert to vertex form. So first example, let's start in vertex form. Y equals 3 times x minus 5 squared plus 2. To get to standard form, I'm going to first expand this. So y equals 3. This exponent 2 means you have the binomial x minus 5 times the binomial x minus 5 plus 2. So I'm going to FOIL this. Y equals 3 times x squared. This will be minus 5x is minus 10x. And then plus 25 plus 2. Distribute the 3. So y equals 3x squared minus 30x plus 75 plus 2. So y equals 3x squared minus 30x plus 77. So vertex form to standard form. Okay, now converting standard form to vertex form. So this can be a little confusing. There is a part of this that is similar to our lesson on completing the square. So what we're going to do, I'm going to write this, I'm going to put the first two terms in parentheses and then leave some space here, and then plus 15 on the outside of parentheses. What we want to do is complete the square. We want to make that perfect square trinomial again using this b over 2 squared. So in this case, negative 8 over 2 squared. Negative 4 squared is positive 16. Now, when you were completing the square, you were doing things on the opposite sides of the equal sign. Now we're going to add the 16 here, and then what we're going to do is the opposite as subtract 16. Because I'm on the same side as this equal sign. So adding 16 and subtracting 16 doesn't really change anything because plus 16 and minus 16 is 0. So now I've created this perfect square trinomial so I can factor it. So it goes to x minus 4 squared, and now 15 minus 16 is minus 1. So there we go. It's in vertex form, which means the vertex of the original parabola would be at 4, -1. Okay, I'm going to do one more example. This one is a little bit more involved because I'm going to have a 2 out in front, this leading coefficient greater than 1. 2x squared plus 12x minus 21. So let's start the same. I'm going to have this 2x squared plus 12x, leave some space, minus 21. Now, I can't do the b over 2 squared when I have this leading coefficient. So I'm going to divide both of these terms by 2. So there I have a 2x squared plus 6x. Now I'll use the 6 as my b. So 6 divided by 2 squared. 3 squared is 9. So I'm going to put plus 9 here. But here, I can't put minus 9. I have to look at this 2 because this is like 2 times 9 is 18. So I have to subtract 18. So now y equals 2, factor this perfect square trinomial, x plus 3 squared minus, combine like terms, that goes to 39. So that is in vertex form, which has the vertex -3, -39. So there's your video on vertex form. Good luck.